All right, boys and girls, welcome to another fun-filled and exciting math video with Mr. Jordan. Today we're going to be looking at section 13.6, which deals with conditional probabilities. Now, in the 13.5 video, Mr. Fagan introduced you just a little bit to this concept of conditional probabilities. And at the end of the video, he showed you this formula here. We were given that the probability of B given A, remember that notation with that line, so this is saying the probability of event B happening given that event A has indeed happened is equal to the probability of A and B happening divided by the probability of A. And this was where the probability of A is not equal to 0, because we know we can't divide by 0. So again, the probability of B happening, given that event A has already happened, is equal to the probability of event A and B happening divided by the probability of A. So you're always dividing by whatever your given probability is there. In this case, event A. So that's what we are dividing by. All right, let's take a look at an example and see how this works. So our first example here says, in a study designed to test the effectiveness of a new drug, half of the volunteers received the drug. The other half of the volunteers received a placebo, a tablet or pill containing no medication. The probability of a volunteer receiving a pill and getting well was 45%. What is the probability of someone getting well given that he receives the drug? All right, so we want to find the probability of getting well given they receive the drug. Okay, well, given our formula there now, we know this is equal to the probability of getting well and receiving the drug divided by the given, okay, well, the piece that was given here, finding the probability of getting well given they receive the drug, so that is the probability that they received the drug. Okay, so that's what we want to set up here. That's the information we need to find here to be able to plug into this to find what our answer is. Well, first off, the probability that they got well and received the drug. Well, as we read through information here, all right, we see in this sentence here, the probability of a volunteer receiving a pill and getting well was 45%. All right, so that's going to be the top of our fraction right there. So the probability of getting well and receiving a drug was 45%, or 0.45. All right, so that goes on the top right there. Okay, and that is all divided by then the given, the probability that they received the drug. All right, so this one's a little tricky. This is where we kind of need to read the problem closely and be able to pull out some information here. So if we look back at the first sentence here, it says, in a study designed to test the effectiveness of a new drug, half of the volunteers received the drug. The other half of the volunteers received a placebo. All right, well, if we want to know the probability that they received the drug, well, it tells us half received the drug. The other half received a placebo. Well, half is 50%. So the probability that they received the drug was 50%. And that's our half of the volunteers received the drug there. All right, so we put this in our calculator, 0.45 divided by 0.5, and we find that the probability of getting well, given you've received the drug, is equal to 0.9, or 90%. And this should intuitively make some sense for us here, because again, they're asking, what's the probability of someone getting well given that they received the drug? Well, if you received the drug versus the placebo, right, you would think I got this medicine that's supposed to make me better. The probability of me getting better, given that I actually got the medicine, well, 90% should be pretty high if it's a medicine worth getting, that is. All right, on the next example here, go ahead and pause your video for a second, work through this one real quick, and then come back and check your answer. All right, so this one here, we should get that the probability that you own a dog given you own a cat, 0.12 divided by 0.27, 0.44 or 44%. And the probability that you own a cat given that you own a dog is going to be 26%. Okay, the wording here was a little tricky. What is the conditional probability that a dog owner also owns a cat? So the given part of that is that they are a dog owner. Okay, that a dog owner. So it's saying you are a dog owner. And then what is the probability you also own a cat? So that's actually our second one, the probability you own a cat given that you own a dog. And then our second question there, conditional probability that a cat owner also owns a dog, that's actually our first one that we did here. So this sentence here goes with the 26%, and this sentence here goes with our 44%. So definitely some of the wording on some of these can be a little tricky, so we need to definitely take our time and slow down and read through these and make sure that we really understand what the question is asking there. Okay. All right, now we're going to take a look at a conditional probability type of problem here. But in this case, we're going to be using a tree diagram to get the information that we need here. All right, so our information here says a college reported the following based on their graduation data. All right, so they have 70% of the freshmen had attended public schools. 60% of their freshmen who had attended public schools graduated within 5 years. 80% of other freshmen graduated within 5 years. All right, so this is a college. They have their freshmen coming in, and they're looking at the high schools that these types of students attended. Okay, so we have public school, and then we have graduated within 5 years. So our first bit of information that we are going to take a look at here is, so did they attend a public school? All right, well, tree diagram, so we got to make branches of our tree here. So our first thing, well, we have that they attended public school or some type of other. Maybe they were homeschooled, maybe they went to private school, whatever it might be. So we know public school, well, it tells us there, that is 70%. And I'm just going to do that as 0.7. Well, the other side of that, if 70% went to public, it must have been 30% or 0.3 that went to some other type of school. All right, now, out of these, we have 60% of freshmen who attended public school graduated within 5 years. So we're on this public school branch here. And off of this public school branch, we have that they either graduated within 5 years or it took them greater than 5 years. All right, and 60% of the freshmen who attended public school graduated within 5 years. So this is our 0.6. Well, the other side of that must be 0.4, so 60% or 40%. Then we are told that 80% of the other freshmen graduate within 5 years. So other freshmen, that was our other part down here, so this is our other branch. Make 2 branches off of this, and again we have 5 years, or we have greater than 5 years. 80% of the other freshmen graduate within 5 years, so there's our 0.8, and more than 5 years then 0.2. All right, so that gives us all of our information there. Now we want to know how many freshmen graduated within 5 years? Well, we've got two different categories of this here, because we have kids who went to public school and graduated within 5 years, and then we have kids who went to other types of schooling for high school and graduated within 5 years here. So we need to find both of these probabilities, and we need to combine them. So first thing we're going to do is we're going to start with our conditional probability formula. So we're going to start probability of B given A equals the probability of A and B divided by the probability of A, divided by our given piece there, okay? Well, the same way in algebra, we can change any formula around to solve for a specific variable there. You know, if it's the area of a triangle, sometimes we want to change that formula around to solve for the height or to solve for the base. Well, we can do the same thing with our formula here. Okay, we want to know how many freshmen graduated within 5 years. So we need to find this probability that they went to public school and graduated within 5 years. We need to find this probability they went to other and graduated within 5 years. Okay, well, we can use this to isolate this probability of A and B. And the way we're going to do that, we're just going to multiply both sides by the probability of A. And that's going to give us the probability of A and B occurring is the probability of B given A occurring times the probability of A occurring. So this is another way that we can use this formula here. Now, if we look at our two separate probabilities that we're looking at here, so first we have the probability that they went to public high school and graduated within 5 years. We see that is the probability of B given A. Now we kind of changed the order of our letters here a little bit. So this was probability of A and B right here. Okay, so public and 5 years. But then we have probability of B given A. So this is a probability that they graduated within 5 years given they went to public school. So if we come back over here to our tree, well, given they went to public school, so that means I'm coming off of this branch. Given they went to public school, what's the probability they graduated within 5 years? Well, 0.6. So this piece here is 0.6. All right, times the probability of A. Well, probability of A and B, so that's the probability of A is the probability they went to public school. So again, come back over here, probability they went to public school. Well, that is 0.7. I multiplied those two together. We get the probability of public and 5 years is equal to 0.42. All right, now we need to do the other side, was the probability of other type of high schooling and, there's not a good and there, and graduated within 5 years. Okay, so now we are looking at, again, probability of A and B is the probability of B given A, so the probability they graduated within 5 years given they went to another type of high school. So we're on this bottom branch now. Well, the probability they graduated within 5 years there, 0.8. So this first piece is 0.8 times, again, the probability of A. In this case, that is my first piece here. So that's the probability they went to another type of high school. So 0.3. So we'll add our 0.3. We multiply those two together. 0.8 times 0.3 is equal to 0.24. All right, so we found the probability public in 5 years, other in 5 years, 0.42 and 0.24. Now if we want to find the total here, so the total of how many freshmen graduated within 5 years, well, that means they went to public and graduated within 5 years, or they went to other and graduated within 5 years. So probability of public in 5 years, or probability other and 5 years. Well, we know with an or probability we are adding, so 0.42 plus 0.24, so our total probability is 0.66, or 66%. So how many freshmen graduated within 5 years? Given this set of data, 66%. All right, the final way we're going to use this conditional probability formula here is this test for independence. And what this is asking, can I say that two events are independent of each other? Or one of these circumstances of one event does not depend on the circumstances of another event. They are entirely independent. And we say that two events, A and B, are independent events if and only if the probability of A given B equals the probability of A, and the probability of B given A equals the probability of B. So both of these have to be true. So let's look at our example here. The 2A frequency table shows the number of juniors and seniors in a school who hold part-time jobs. Teacher selects one junior or one senior at random. Consider events A and B below. Are the events independent? Use probabilities to determine your answer. All right, so event A is that the selected student is a senior, right? And event B is that the selected student has a part-time job. All right, so if these are going to be independent, we need to find the conditional probability. So let's start with this first piece here. So we want to find the probability of A given B. So this is the probability of A and B divided by the probability of B, our given piece there. So we're saying what's the probability that the selected student is a senior given the selected student has a part-time job? Well, that's the probability that they are a senior and have a part-time job divided by the probability that they have a part-time job. So let's look at our numbers here. Well, probability of A and B. So selected student is a senior and has a part-time job. Well, if I look at my table, seniors who have a part-time job, there are 95 of those. So 95. Okay, and my event B, okay, the selected student has a part-time job, so the probability that they have a part-time job, well, 166 have a part-time job. All right, so that is my first one right there. Probability of A given B is 95 out of 166. And if these two events are going to be independent, then this here needs to be equal to the probability of A. So the probability the selected student is a senior. Okay? Well, probably the selected student is a senior here. So let's look at our information. Well, how many seniors do we have? So the probability the selected student is a senior, well, there are 181 seniors. And selecting a student, so I just want to know how many total students there are here. Well, there are 356 here. So I have 95 out of 166, and 181 out of 356. All right, we put these couple in our calculator real quick just to check to see what they're going to be. So 95 out of 166. That's going to give us approximately 0.57. And 181 out of 356 gives us approximately 0.51. So since these two numbers here are not equal, these events are not independent. All right, now if these had been equal, we wouldn't have been able to assume at that point that they were independent. All right, we would still need to then check the other half. Okay, we would need to check the probability of B given A to see if that was equal to the probability of B. But since our first one here was not equal, we can already conclude that these two events are not independent. All right, now definitely these concepts in this section here are probably a little trickier than the ones we've looked at so far in probability. I'd encourage you to go back and maybe rewatch parts that were a little confusing for you. Definitely ask your teacher some questions, and there are always additional resources out there, a quick little Google search away if you need additional help as well.